So hi, I'm Iris, and today I'll talk about a summer project that I took part in this past summer in partnership with Johnson County. We were a group of 4 fellows, myself, Christiana, Alden, and Ben, and one mentor, which is Pedro. Just a sec, let's make sure that I can go next. So who am I? First of all, I'm a PhD candidate at the Weizmann Institute of Science. Before that, I pursued a bachelor degree in computer science, majoring in bioinformatics in the Technion, and a master's degree in systems biology in the Weizmann Institute. And the section which I'm going to talk about, which was between my master's degree and my PhD, was being a summer fellow in University of Chicago at the Data Science for Social Good program. Obviously, if you have any questions during the talk, then feel free to ask them. I wanted to say that beforehand also. So what is Data Science for Social Good? It's a summer program by the University of Chicago. It's held every year, and actually applications opened a week ago. So if you're free this summer and you're even considering it, come talk to me afterwards. I highly recommend it. America's largest mental hospital is a jail. Now, this statement was said about Chicago, but ask any person who's in charge or somehow manages a jail system within America, and you'll find that they'll agree with this statement quite strongly. So we partnered with Johnson County, Kansas. You can see here Kansas in red at the left, and within it, Johnson County, which is kind of unique because it borders not only with other counties, but also with state border to Missouri. So we partnered with them trying to fix that issue of jails being mental health facilities. We came there and we heard a story about a 19-year-old male who has autism, but also some intellectual disabilities. He had over 100 police encounters, which is by itself somewhat disturbing. However, out of all those 100 plus police encounters, only one of them ended up with a jail booking. And that one is considered as a horrendous failure. But in general, the county wants to eliminate these cases where people are sent to jail and instead they should actually receive mental health assistance. And that's where we come in, because we wanted to change the way the mental health system works from being reactive to being proactive. And to do that, we yield machine learning tools. So our role was to predict individuals in risk of entering the jail system in the next 12 months. And we put out that list every month. And of those people, the 200 with the highest risk are being reached by the mental health system, okay? So what is currently going on? I mean, before we started. So they had the regular reactive intervention. Someone has a crisis, somebody else calls about them, or they come to the mental health department, and then they get assistance. Also, if they have a booking, then once they're booked, they go through the brief mental health screen. That screen tests, it's a 7-question screen. It's very simple, but it simply tests some of the main mental health issues. For example, do you hear voices talking to you? And things like that, that can show that this person needs mental health assistance. If they get a high score, then once they leave the jail system, this will define whether or not they'll get assistance within the jail system, but also once they leave. So if they get a really high score, meaning they definitely need mental health assistance, they will be outreached once they leave the jail. Also, if they were a mental health client beforehand, they will also be outreached once they leave the jail. But what about all the cases that fall in between? Those cases that we can prevent them from being booked, and cases that once they leave the jail system, maybe they need outreach, but they weren't really caught by these 2 very distinct measures. So to that, we yielded a lot of data. Specifically, Johnson County, Kansas holds all of their data, especially jail data, from '93. They were the first in the United States to have all of this data being only electronic. So we got jail data, we got data from police departments, we got data from the Department of Corrections, which is a Kansas facility. This means prisons and not jails. We got public health data, we got data about emergency medical services, just a sec, and we got mental health data. Yeah. Okay, so for the Hebrew speakers, jail is matzal, meaning this is when you get arrested and have not yet been declared a felon. Once you become a felon, then you go to prison. That's the difference, which is probably why jail holds a lot of people, especially in the US, that are not necessarily felons, and they might even stay there for a very long time. So who do we predict? I mean, that was our first question as data scientists. Who are we going to predict? And we looked at two very distinct cases. The first one is people who it is their first booking. Now, obviously, if you intervene at that early stage before the first booking, you're going to make a very big difference. However, if you predict a recidivism, meaning a second or more time within the jail system, then it's easier to predict. You know a lot about that person. However, you might not be as assistive as you could be. And we wanted to quantify these things before we answer that question. So obviously one is more proactive than the other. But also, how many of the people are currently targeted? And we found that less than 1% of people before their first booking are targeted by the current intervention from the Department of Mental Health. And about 25% from people who have already been to jail are targeted again, by the Department of Mental Health. And then we asked, what percentage of booking does each one of the population consist? So this is the number of bookings. The x-axis is the nth booking, meaning first, second, third, or more. And the y-axis is the percentage from the entire bookings. This is for 2017. It looks about the same for every year. So you can see that about 23% are first bookings and 77% are second or more booking, which is quite a lot. And then we asked, what percent of the people are going to be booked in the next year? And so, again, we did this for 2017. It looks similar for every other year. We looked at the number of bookings, number of prior bookings this time. So we start from 0. And we asked what percentage of the people are going to be booked. And you can see that it's very low, obviously, for people who have never been booked. And it's much higher the more bookings you've had before, with some noise within it. So in total, less than 0.5% of people that we have data on are going to be booked in the next year. And about 7% of people that we have data on and have been booked before are going to be booked in the next year. And then came the question about data. Do we even know anything about the people who are going to be booked in the first time? So we looked at all our data sources, and we found that altogether, they account to about 1/2 of the number of people who are going to be booked for the first time. And from this accounting, notice the police department. Most of them are actually the arrest a day before the jail. So obviously, that's not really going to help us. So in general, we don't have a lot of data about people before their first booking. And after the first booking, because of the operation happening during the first booking, we already have a lot of data. Like I mentioned before, we have a brief jail mental health, and we have a lot of other information about them. So in total, we come to the understanding that precision for predicting the first booking will be vastly lower than predicting recidivism. And so we decided to tackle the problem of recidivism, although now the team that took over the project from us is tackling the other problem. And so we looked at examples from the data. I mean, it's nice to think about how many people we could help, but we wanted to see a concrete example. And I will say that this is somewhat upsetting. We looked for someone who intervened with multiple systems. We didn't expect this. All right, now moving. So just if you can't hear me, tell me. What we see here, this is the arrest, meaning the specific information associated to the jail and arrests. And these are other sources we have. We have public health data, which only starts from 2004, if I recall correctly. We have the mental health, which starts later, and emergency medical services, meaning ambulances, which starts even later. So this is a white female. She was born in 1975. She had her first DUI with a bond of 300. Apparently, she did something to break that bond. You can see that it's the same color, meaning it's the same case number. So for some reason, her bond got up to $1,000, and then she spent time in prison. Afterwards, she had another case And then she had a theft, and she spent time in jail due to that theft. And she went to family planning. Now, family planning doesn't mean she had a baby. It means she had abortions. We were confused about that as well. And then she had another DUI. She drove without a license, and she went to mental health care. We thought, oh, that's awesome. She went to get some help. Not really. This is court demanded because it's once a week for exactly a year. So it's court demanded due to the DUI. She did nothing above come to like AA meetings. Okay. And so our question is, should we assist her? Do we think that mental health department can help her and can change her outcome? Now, actually, when running the model, she probably gets a pretty high probability of needing assistance. And if we look at her future outcome, we can see that we could have changed her life quite a lot. She had several additional cases after those incidents, and her tackle with law enforcement, including losing custody of her children and drug-associated arrests. And so we went on to define our baseline. Obviously, for every model, you want a baseline. You want to compare yourself to something. But we're comparing ourselves to proactive mental health outreach, which doesn't exist. So are we going to compare ourselves to zero? Because that kind of sounds like we're saying we're really great, but let's admit that's not good enough. So we looked at existing baselines. First one is LSIR. LSIR these are different surveys that are already existing in the county. It calculates risk of recidivism, which is exactly what we're calculating. However, it's given to people when before they start their sentence in the prison, which means it's convicted felons, not exactly the people we're looking at. It's a much smaller population. So that's not good enough for us. We looked at the brief jail mental health screen, which I've mentioned earlier. So it's given to all people who are booked in jail. That's our population. However, it looks for the need for mental health assistance, not exactly what we're looking for, because we look for people who are going to enter the jail system again and then outreach mental health to them as a solution, but not necessarily people who need mental health help. And it's given at the moment when they start their jail term, which is, again, it's a single time point. It doesn't give you an updated value about the screen, unlike what we want, which is changing due to other data sets that we have information on that specific individual. And then there's pretrial screen. This pretrial screen looks for, are you going to appear in court or not? This sets the value for your bond, and it looks into all people who are booked into jail. And again, it's pretrial, so it only happens once, and it doesn't really get updated. So again, not very useful to us. So what we've decided to do is to create a decision tree using the most known features from literature, which is the age of the first booking and how many bookings a person had beforehand. Now, this will obviously change over time, so we can do this to each date, and it's for everyone we know. And also, this predicts risk of recidivism because that's what we're training our model on. So we created our own baseline, and it actually did quite well. So what you see here is when you choose the percentage of the population, what is going to be your precision? That's the blue one. And what's going to be your recall? The red one. So obviously, you want really high precision. And what we see, it's really difficult because the line is not really at 200 people, and we want to give 200 people a month. But 200 is actually like in the zero, so we tried to draw it nicer. But in total, it's 47%. So that's quite good just for like 2 features. And so we created our own model. We tried to train a lot of models. As you can see, we use different model types. For each model type, we used every possible set of hyperparameters from the sets written here. There's a lot of them, as you can see. But in total, we used the model types of extra tree classifier, random forest classifier, decision tree classifier, and logistic regression. And again, a lot of hyperparameters. And then we asked ourselves, how do we choose the best model? So I know this is really awful to look at, but what are we seeing here? So on the y-axis, we're seeing the precision. Each line, and again, I know you can't really see lines, so trust me. Each line is a type of model with specific hyperparameters from the previous slide. So, for example, one line can be a decision tree with a specific number of trees and all the other hyperparameters. And then the x-axis is over time. Let's say we trained it in May 2013, in May 2014, 2015, and 2016. So we want our model not only to be the most precise, but we want it to be the most precise over time, because if it's really noisy, then that's not good enough for us. It's not going to actually be useful for our client, because they're not going to trust the model over time. Out of all of this, the best was a random forest classifier with the highlighted hyperparameters. Honestly, they kind of mean nothing, but it is a random forest classifier. And this is how it looks compared to the baseline. As you can see, we do a lot better. We actually do about 70% precision for the 200 people picked to be outreached by the mental health facilities. And even those that we get wrong, meaning that they don't really have jail time within the next year, have a jail time within the next 2 years. So we're not that far off. And so we were kind of pleased with this, but this is not it. We continued to asking ourselves, how do we make sure that we don't do harm when we try to do good? And this is where we looked into bias and fairness. So we wanted our model to be fair in terms of gender, race, and age, because if it somehow misbehaves, then we're actually doing harm to the county, right? We used this is an open source package. It's called Akitas. And you're welcome to use it, but you're also welcome to contribute to it. We've contributed during our time there, and I highly suggest using it. It also has a web app if you want. Like, I don't know why would you not want the Python API, but if you want. So our first question is, what is the number of re-entries to jail according to race? And what we see is that it's actually quite similar between African Americans and whites. The orange one is people who return to jail. The blue ones is the ones who don't return to jail in the next year. So you can see that obviously there's more white people in general, but also more of them go back to jail, and it seems somewhat similar. And then we ask ourselves, and this is going to be like you're going to answer the question, so I'm not going to answer for you. We asked ourselves, what is the measurement we want to look at? So the first question is, do you want to be fair based on disparate representation or based on disparate errors on your system? So do we want to represent the same number or this of whites and blacks, or do we want to be wrong on the same percentage? What do you say? Come on.
Wrong.
Thank you. So we're based on errors. Thank you, Noah. So then we ask ourselves, is our intervention punitive or assistive? In our case, our intervention is mental health. So as someone said here, assistive. Thank you. And then we ask, are we intervening on a very small percentage of the population? Now recall the image from later. Very small? Yes. And so we're going to look at false omission rates, which is calculated this way. It's the false negatives divided by the false negatives plus the true negatives. We don't want to miss people because of what group they are part of, okay? This is what it actually means. And so this is the entire schema if you want it. It's also available in the Akitas website. Just like I thought it would be easy to see. So we looked at false omission rates by groups. And the head one is by race, second one is by sex, and the last one is by age. Does anything seem suspicious? The age, yes. So race and sex, we generally are fine, but age, we're missing a lot of people who are under 25. Compared to the people above 55, we're hardly missing any of them. Any idea as to why? Yes?
Lack of data, lack of records, data of the age gets to be admitted.
Exactly. Perfect. So yeah, we didn't know that we don't have data for under 18. We thought, well, we had a table that said juvenile arrest and we just used it and we assumed that we have all the data. No, we don't. We didn't really have their IDs. It was like a mix of IDs and they didn't fit to their adult IDs. And so we were missing a lot of this data, which means that when we gave this tool to our partners, we told them, listen, you got to fix that one. You got to make sure that you're using the same IDs for both. And you got to make sure, because you have the availability and we don't, you got to make sure that you're okay on age. But we gave them this tool. So once they train a new model, they're going to see this. They're going to see if they're missing something, if they're not behaving somehow. And then we also gave them another tool because we felt like that wasn't enough. Our tool, the first tool you saw, was for each model on its own. But this tool allows them to choose a model according to their own decision. So what you see on the y-axis is the false omission rate disparity. Given two different groups, you divide the false omission rate between the two of them. You want the value to be as close to 1 as possible. And then you look at the evaluation metric. In our case, it's precision. So in general, you want to be on the y-axis as close to 1 as possible, and on the x-axis as much to the right as possible. Again, close to 1. So here, in this image, you'll want the orange ones that are on the top right. These three both have good false omission rate disparities. They don't really differentiate between female and male, but also they have quite good precision rates. So this allows our clients to actually take a look and understand for themselves what is their decision and make a more informed decision at that. So they see this, each dot is a model. They see it for males and females, but then they also see that according to race. And as you can see, according to race is a bit noisier. And now it's actually the same 2 oranges and 1 orange, but you can see that the 2 oranges actually have a much better false omission rate disparity than the one that was earlier on top. And then you'd probably want to use those 2. So this gives them a better understanding of which model they should actually use. So in summary, what we did is we converted a reactive system of mental health outreach to a proactive one. We used machine learning for that, obviously. We gave a closed system for non-CS clients. And trust me, this was a hard task because explaining to them what they see in the graph took me about 5 hours. And I am being really kind to them. And in total, we allowed users to account for fairness and equitability by themselves, not taking the handles on it to the model, but rather telling them, look, you need to be aware of this. You need to account for it. You need to know what goes on in the model. So what's next for the project? The project is actually now being implemented in Johnson County. There's a lot to test to see that mental outreach is the right result, to see that we're actually flagging the right people, and to see that we can actually reach them. Because obviously, calling someone and telling them, hey, do you want mental health assistance? We believe you need this because you're going back to jail is not the right solution. So all of this is currently going on by our partners and with a team of data scientists from UChicago. And they're moving this forward. And this is actually a project that's intended to continue about more than a year from now. So hopefully it will yield really good results and will become a beacon for other governments within the US and hopefully outside as well. Thank you. And now I'll answer questions.